Yes, we are. Go. All right. All right, so welcome to MMANet. My name is Rui.
And I'm Johnny.
So MMA, or mixed martial arts, is a recent sport where two fighters fight to determine who's the better fighter, and no restriction on styles. So MMA, a huge part of it is actually unpredictability, because there's lots of factors that go into every individual's fight. So we wanted to see if we could analyze the fighter data as well as fight data from every single fight to see if we could predict the outcome of a fight. So some considerations that we thought of before is what if MMA is not popular enough to have well-compiled data, or the fact that many fighters do not have a lot of fight data to use. So this is an example of some fight statistics that were drawn for each fighter. So their pace, their knockdowns, their accuracy, the areas that they strike at. So this is only a small sample of them.
Okay, so for our data, we use the Kaggle dataset with unprocessed UFC fight data. So there's one label for the winner and then 13 one-hot encoded label for the weight class. And then we have 72 fight statistics for each fighter. So in total, we have a binary classification problem with 157 features and 3,592 data points. So after this, we chose to do some visualization to see how each of the features are affecting the label. And we can see that fighters with more unanimous wins and with more experience tend to have a higher chance of winning.
So the Kaggle dataset had to be cleaned, of course. There were empty values. So empty values in the fight statistics meant that there were no prior history. So we filled those with 0, but the empty values in the fight details, the fighter details meant that this data had to be cleaned, had to be removed. So the data was encoded, some features were removed as they were not relevant to the classification problem, such as the title bout was unnecessary information.
So after this, we did some pre-processing on the data. So we normalized so that the values are between 0 and 1. We didn't do 0 mean and univariate because it sort of blew up the data since we had really low variance. And also negative values didn't really make sense. And then we split the data in 2 ways. So we did an 80, 10, and 10 split for training, validation, and testing. Also, we split into 5 groups so we could do 5-fold cross-validation. And then we played around with some feature extraction to try to reduce the dimensionality of the data. So we tried a few different techniques. Here we're showing 2-dimensional PCA just because it's something we can actually graph and how it splits the data. You don't see a really good split. Yeah. And then for our baseline, we chose to use a random forest classifier with 100 decision trees and no set maxed effort trees.
Right, so our model that we came to in the end was a 4-layer multi-layer perceptron. It had a batch norm applied after every single layer, and it went from 158 inputs to 10 to 10 to 10 to 1. It had sigmoid activation for all of the neurons, binary cross-entropy loss, and the atom optimizer. So this was chosen after many, many trials. And the hyperparameters that trained it best, 27 epochs, learning rate of that number, weight decay of 0.001, and a batch size of 64.
Yeah, so the baseline got validation accuracy of 65.3% and testing accuracy of 65%.
And our architecture got a validation accuracy of 67.5 and a testing accuracy of 65.8%. So this is just the graph of the training accuracy and the validation accuracy. This is the accuracy over a lot more epochs. So you can see that it rapidly overfits. And this is also just the loss. And after we had our model, we decided to run some tests on some recent fights. So these are fights from around a month ago, and that model did not train, validate, or test on, just so we could visualize how Vegas did, so what Vegas predicts will be the winner, and how our model did. So you can see that Vegas is actually quite accurate, 75%, and our model was not bad, 64%.
Yeah, so just discussing some challenges that we had in our project. Different data sets that are available had very different metrics, and they're structured very differently, so it's very hard to merge and reconcile the different data sets. As well, we tested with some granular and advanced metrics, but they were not as useful as we had predicted. Furthermore, there's not a lot of previous history for many of the fighters, with a lot of fighters most fighters actually, having just like 3 fights in their entire career, which is much less than, say, in the NBA, where they have a lot of basketball games. And each fight is only a maximum of 25 minutes. And we only used UFC data as the highest level of competition, and we didn't use any of the other fighting leagues.
Some more discussion. So as you can see, the MLP was not much of an improvement over the baseline. And this was probably because of just the lack of data. There was only 3,592 data points. And this was actually going back all the way to 1993. So MMA is actually quite a new sport. And I guess there was just not enough data to use. And even though it was a 75% accuracy that we showed, Vegas tends to be around 70% of the time. So Vegas doesn't get it right all the time either. As well, meta changes. So what I mean by meta changes is that the styles that won back then, 10, 20 years ago, are very different. And there's the styles change over time. So fighters that win now may not have won 20 years ago and vice versa. And finally, there are many factors that we did not consider, such as mental state, the environment, the coaching, maybe even hometown bias. And these were not, you can't encode these into something that the MLP can take in. Right, so in the end, we still have some improvements that we did not put on here.
Yeah, some improvements we were thinking of were maybe using image and video data so we can glean more insights, such as the quality of a fighter's muscles, as well as maybe their fighting styles. And then also we considered weighting their statistics based on the strength of their schedule and their past fights. So if they fight against harder or worse opponents, you weight the statistics differently.
Right, so maybe in the end, MMA will always be unpredictable. Thank you for listening.
So that last thing you said, I think would be important, knowing how well a fighter did against other fighters,
right,
and knowing the rating of the other fighters. So none of this takes that into account.
No, so our data set has the previous statistics of the opponents, but it doesn't distinguish between like which opponents were, were better or worse. So in the future, if we had more time, we would have gone through like chronologically, like this fighter had this record at the time and weighed those differently. And also we should have weighed losses and wins more heavily towards more recent fights, because losses 5 years ago don't really yeah.
Wait, could you go to the PCA slide?
Sure.
So this wasn't useful for classification between winner and loser, but it clearly is making 4 different clusters there. Do you know the interpretation of that? What are those 4 different clusters that it's made?
4 different clusters? Well, for this one, this was actually ran on this was ran just on the training data, and what we did with the home data set, it didn't actually make these 4 clusters. So they're not too learn like that.
Because it's clearly found some way to partition
Right,
different,
so
different
this
data
could be one
points.
of those values that are like very, how do I say, like certain like unanimous decisions. There's only a very set amount of like wins that a fighter usually has. So like most fighters have 1 or 2 or 3 or 4 wins. So it may have clustered like that. I'm not too sure.
It'd be an interesting thing to figure out. Another question I had is, with the Vegas slide you had, it'd be interesting to just see what your expected financial return of your model would have been.
Oh, that's a very good point. Yeah. Oh, right. So that's very important to discuss too, because some of the flights.
Actually, we're going to cut
Maybe
you off
for
on
another
that. That's about economics, but we'll have to move on to the last one.
All right. Thank you so much.